Hello, this is Les. Welcome to my YouTube channel. This is an odds and ends engine. The plans and drawings were made by Philip Duclos. I think I'm saying his name right. The drawings were published in the Home Shop Machinist in the mid-1980s. A lot of model makers built this engine. In fact, if you search odds and ends engine on YouTube, you'll see a lot of other videos on this engine. In fact, one fella has a whole series showing the building of this engine, which is very interesting. It's a 4-stroke spark ignition internal combustion engine. Uses gasoline for fuel. It's also a hit and miss engine. The governor has a flywheel that controls the engine speed and how often the engine fires. I'll kind of try to demonstrate how that works. The governor's on this side. These little weights are held in by these springs, and when they fling out, they hold the exhaust valve open, and when the exhaust valve is open, the engine just coasts. There's no compression, there's no drawing in of fuel, so the engine doesn't fire. And as the engine slows down, the weights go back in, and then the engine fires. So if the engine is working hard under a load, it fires rapidly, probably continuously, and then as the load lightens, it starts to coast again. I built this engine about 30 years ago. I couldn't get it to run. I gave up and put it on the shelf, and it sat there and gathered dust for about 30 years. The engine is built from angle iron and bar stock. These two side rails right here are two pieces of angle iron that are cut out and bolted together. It has a cylinder sleeve made out of a piece of cast iron, and it originally had cast iron piston rings. A couple of weeks ago, maybe 3 weeks ago or so, I decided to try and get it to run and paint it up and finish it. And I did get it to run. I'll demonstrate that in a little bit. During the period of time it was sitting on the shelf, it had fallen to the ground and bent the crankshaft. So I had to straighten the crankshaft. And it still has a little bit of a wobble to it, but I was able to straighten it pretty good. Another problem was that the cylinder wasn't bored very straight. It had a little bit of a taper to it, which resulted in poor compression. So I made a cylinder head for it, so I could fix that problem by boring right straight through and truing that cylinder up. I also made a new aluminum piston with a Vitron piston ring, and so I have good compression now. Another change from the original was the installation of a hall sensor. This little wheel right here has the magnet. The Hall sensor is mounted in this block of plastic. The ignition system is underneath. And this is the battery box right here. Okay, so I'm going to open the window now for ventilation and try to start the engine. And you prime the engine by putting your finger over the air intake. This is for water cooling. You put water in this little tank right here on the top. It surrounds the cylinder. I didn't put any water in it because I don't know how long I'm going to run it. It doesn't seem to be getting very hot. Right here by the exhaust is where it would get the hottest. Since it isn't firing continually, I don't think it gets too hot. I don't know if I can demonstrate this, but as there's a load on the engine, it should start firing more. This turns the gas off, so it should stop.